All right, let's see how you did on the first example. Okay, so the first thing that we're going to do is we know that this is an arithmetic series, so hopefully you were able to find the equation. If you notice, your common difference right here is 10. So every single time you're adding 10, and our first term is 100. You're going to plug that into your formula, your first term plus your common difference times n minus 1. This is just my simplified version of 90 plus 10n, which is what I'm choosing to use just because it makes it a little bit simpler. All right, so our rule is a sub n equals 90 plus 10n. Okay, our summation notation, so we're summing the first 18 terms. So we know n equals 1 at the bottom, and then 18 is at the top because I'm only going to 18 terms. Okay, so remember previously we talked about what convergent means. So let's just take a second and talk about what convergent versus divergent means. So convergent means that there actually is a sum. So I can find the sum of the numbers. So here in this case, I'm finding the sum of 18 numbers. So this is a convergent series because I can find the sum. Now, if I change this to be n equals 1 to infinity, that is going to be called a divergent series. And the reason that that is divergent is because I cannot find that sum. There is no sum. So convergent is I can find the sum. Divergent is I cannot find the sum. If I'm going from 1 to infinity, then there's an infinite number of terms to add, so I can't actually add them. Therefore, it's going to be divergent, okay? Now, an arithmetic series, okay, that goes to infinity is always going to be divergent. If it has a specific sum that you're finding from 1 to 5, 1 to 15, something like that, that is going to be convergent. But if we're just talking about the series to infinity, it's always going to be divergent. Okay, so when we find the sum of the first 18 terms, remember you need your first term. That was 100, that was given to us. Our 18th term, which was 270, so that's just plugging in 18 into your formula here, and then plugging that information into your summation formula. If you have any questions on that, please let me know, and I'm happy to help. All right, this one's a little bit trickier. So it says find the value of n such that the sum is equal to 600. So this is asking us how many numbers do I have to add in order to get a sum of 600. So we know our formula is S sub n equals n, the number of terms I'm adding, times my first term, plus my nth term all over 2. And let's think about what we have. So first of all, what do we know? We know we have S sub n is 600. So we know what we want that sum to be. So let's go ahead and fill that in. Okay, we don't know how many terms we're adding, so we're going to leave that as n. We know our first term from our series is 100. Okay, so I can fill that in. Okay, my a sub n is going to be a little bit of the trickier part. I don't know what my a sub n is. However, here's what I do know. I know, okay, a sub n is this particular formula right here. So I know a sub n is 90 plus 10n. So in place of a sub n, I'm going to put the actual formula, which is 90 plus 10n, because that's how I get my a sub n value. I don't have it yet, but that's how I get it, all divided by 2. So what you're going to do now is all you're going to do is basically use your algebra skills in order to solve this. So you're going to get 1200 is equal to n times, okay, and then you're going to combine like terms so that you have 190 plus 10n. Okay, and then you're going to distribute. So you have 1200 equals 190n plus 10n squared. Hopefully you recognize here that this is a quadratic. So what we're going to do is we're either going to solve this by factoring or using the quadratic formula. So make sure you get everything over to one side. So you have 10n squared plus 190n minus 1200 equals 0. So you can use the quadratic formula here, or I would suggest factoring out a 10, and you're left with n squared plus 19n minus 120 equals 0. Once you divide everything by 10, that'll cancel that out. So you're left with n squared plus 19n minus 120 equals 0. So now let's factor this. So just go ahead, take a minute, try to factor this. You can hit pause, and then once you're ready to see the answer, go ahead and hit play. All right, so this is going to end up factoring into n minus 5 and n plus 24 equals 0. So we get two answers, n is equal to 5 and n is equal to negative 24. Your answer here, since we're looking for how many, we can't add a negative number of terms. So since we can only add a positive number of terms, it's just going to be n is equal to 5. Okay, so when I add 5 terms up, it's going to give me a sum of 600. All right, so let's take a look at our second example here. Okay, so for our second example here, what I would like you to do, hopefully you've tried this on your own, and then after you've tried this on your own, you're going to check your answer here. So first thing we're going to do is write the rule. Our rule, so first of all, we know our common difference for subtracting 3 each time. All right, so our difference is negative 3, and our first term is positive 34. All right, so then you're just going to fill your numbers into your formula. You have your first term minus your common difference times n minus 1. The simplified version is just 37 minus 3n. So I'm going to use that as my general rule just because it's a little bit shorter. All right, so this right here, notice with this dot, 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 I'm just going to go over this portion. This is a divergent series, okay? And the reason that this is divergent the way this is because those 3 dots are going to tell us that that goes to infinity, and divergent means that there is no sum. If I keep adding, think about my number is going to get bigger, 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 and there's going to be no finite sum. So that particular example is going to be a divergent series. Divergent means there's no sum. All right, so how would I write this in summation notation? Because I'm finding the sum of the first 132 terms. Okay, so I'm adding the first 132 terms. So remember, sigma means sum, and then I'm just summing the rule 37 minus 3n. Okay, now this right here, this summation is convergent. Why is this convergent? Because I can actually find the sum. I can find the sum of 132 terms. I'm actually going to get an answer. However, if I write it to look like this, n equals 1 to infinity of 37 minus 3n, that is going to be divergent. Why is that divergent? Well, because I can never actually sum infinity amount of terms. Okay, so that is going to be a divergent. I cannot find the sum in that case because there is, cannot find this fun. All right, I cannot find the sum. All right, it's never going to give me a finite answer. So there's your difference between convergent and divergent series. So the sum of your first 132 terms was negative 21,450. Okay, and remember that formula is going to be S sub n is equal to n times your first term plus your nth term divided by 2. So in this case, we know that n is equal to 132. Make sure you've tried this. A sub 1 is going to be our first term, which was 34. And in order to get A sub 132, you're going to need to plug that into 37 minus 3 times 132 to plug all that information into your formula. All right, and hopefully you've tried letter B here also. Okay, so letter B here is telling us find the value of n such that the sum is equal to negative 12. All right, so filling our information in, we know that the sum is negative 12. So that's going to go right here. N is going to stay because I don't know how many terms there are. We know that my first term is 34. Now this was the tricky part, a sub n. We don't know what that value is going to be because we don't know what the n value is. But we have a general formula. Okay, notice how I'm just substituting a sub n with a general formula, which is 37 minus 3n, all divided by 2. All right, so let's just take you through how to solve this. So you should have set up your equation, multiply, make sure that you're multiplying 2 to both sides. So you get negative 24 equals n times 71 minus 3n. Then distribute your n in. So you have 71n minus 3n squared. Hopefully you recognized here that this was a quadratic. So since it's a quadratic, you're going to want to set everything equal to 0. So I moved the 3n and the 71 over to the other side so that the negative 3n squared would become positive. So you have positive 3n squared minus 71n minus 24 equals 0. You have a couple choices once you get to this point. You can factor it. You can use the quadratic formula or you can use Desmos. Remember, if you use Desmos, what you're checking to see is you're checking to see where it crosses the x-axis, okay? So here's what mine looks like on Desmos right here. So you have negative 1/3 and 24. Okay, so this was my graph, and obviously we can only use the positive answer because I can't sum a negative amount. All right, or you could factor. It factors into 3n plus 1 times n minus 24. Factoring by grouping or guess and check is what you're going to want to use here. Then you solve and you get n is equal to negative 1/3 and n is equal to 24. But I only want to use the 24 because I cannot sum a negative amount right here. All right, so find the value of n. The sum is negative 12. So in this case, n is equal to 24. So I sum 24 terms. This is convergent. Okay, this series is convergent because I could actually find the sum. All right, I found the sum is equal to 24.